2.
Good afternoon, Howard Wig, Code Green, Think Tech, Hawaii. My honorable guest today will be talking about Moore's Law. No, not exactly Moore's Law. Be talking about Moore's Law as it applies to the battery world. It gives me a great pleasure to introduce Sam Monet, I assume the grandson or great-grandson of the painter?
Yes, absolutely. I have all the money.
And Mark Watt, my colleague in the State Energy Office, he is our civil defense guy, and a lot of Sam's talk about batteries is going to concern what the batteries are capable of in the event of a civil emergency. Big data will enable power sector to add far more intelligence to the grid, and Sam will be talking about this, and to have a far better insight into the operational conditions of utilities. Sound good, Sam?
Sounds good to me.
So, enough of me. Sam Monet, the managing partner of Plug and Play Energy Systems. There's a whole variety of these storage batteries out there. And incidentally, when we're talking batteries, we're not talking little flashlight batteries. We're talking batteries that are anywhere from, say, size of a small refrigerator for a home to, say, a 40-foot Matson truck or Matson container that just holds nothing but batteries. That's the scale that we're talking about. So, and Sam's variety of battery is sodium nickel, and I bet he's going to tell us why sodium nickel is good. And we do have a PowerPoint presentation, so if we could get rolling on that one. And take it away, Sam.
Well, Howard, thanks for having me on the show.
Mm-hmm.
It's a pleasure being here, and I'm not an expert in batteries. I know a little bit about batteries, but we have some experts in our company that are engineers and who understand these things really well. First of all, batteries are the key to the future grid. Without battery storage, the grid is not going to be able to go 100%. It's renewable. It's just not possible. So we all better get used to it, and batteries need to be safe.
Yep.
If your battery is combustible, you don't want it sitting under your bed or in your garage.
Mm-hmm.
If a utility scale battery, a 1 megawatt battery that's in, say, a 20-foot container is combustible, you don't want it in a residential neighborhood.
Mm-hmm.
So part of the problems with batteries is that some of them are unsafe. Now, the screen that we're looking at right now, that's the Oahu grid right now. It's a dumb grid. Okay, there's no batteries on it, actually.
And by grid, we mean the way that Hawaiian Electric distributes power throughout Oahu.
Yes, you can see that the wind is out in Kahuku. And actually, the batteries that were in place out there, they were lead acid batteries, and they caught fire a couple of years ago. And so the Hawaiian Electric allowed the developer to go to capacitors, which don't do the same job as the battery. However, it's better than nothing.
Mm-hmm.
And so what we're going to do tonight is we're going to figure out a way to turn that dumb grid into a smart grid,
Mm-hmm.
using distributed energy resources, DERs,
Mm-hmm.
as they're called. So a distributed energy resource, or a DER, is a small-scale generating and storage facility, usually about 10 megawatts or less. And this screen right here shows what Oahu could be with DERs located in remote areas like Haleiwa, Makaha, Kahuku, Hawaii Kai, Halemanu in Wahiawa, Manoa at the University of Hawaii in that area, and even at Lagoon Drive or Waikiki. Mm-hmm. So if you distribute battery storage to all of these locations, not only will you smooth the grid, but on a public safety scale, let's say that the hurricane comes through and does what it did to Kauai, in '92. And by the way, I was there on Kauai in '92, and I saw what happens. Everything gets
Mm-hmm.
knocked down. They bulldoze all of the power lines to the side of the road to clear things for public safety cars and things like that.
Yeah.
And then eventually they get to restoring the grid. So if you live out in Makaha, you'll be last. If you're in Hawaii Kai, you'll also be last on the schedule. And so we're going to be looking at ways to turn our Oahu grid into a smart grid using our batteries that we sell and install
incidentally,
and plug and play.
Hurricane, it's not, you heard it from me first, it's not if, it's when. We dodged how many hurricanes, Mark?
Oh,
15.
15
15
tropical
last year,
cyclones
yep.
were in the Central Pacific Basin this season.
And this is way before hurricane season, but what's happening near the equator as we speak?
Is El Nino.
El Nino, and the first hurricane has already
already
developed.
Polly.
Yeah.
Polly is
Polly,
actually might become a hurricane later on today, and it's generating waves on the South Shore right now, which was really good for me this morning. I got some waves before coming here, and you know, as a competitive surfer and sailor and a surfer, the first thing I check every morning is the waves and the wind. And you know, we're having fewer trade wind days. We're having much fewer trade wind days, and the doldrums are expanding. So.
Yeah, El Nino is supposed to be with us this year again.
Exactly.
So,
yeah.
anyway, hurricanes will come. So are we ready for our next slide then?
Absolutely.
Yeah.
But this is a really neat site, okay? This is put up by Blue Planet. It gives you real-time data as to how much power is being produced by various sources here in Hawaii on a minute-by-minute basis. And I took this screen yesterday afternoon at about 4 o'clock. And lots of squiggly lines, some straight lines, but basically the gray line is coal. And coal keeps generating at a fairly constant rate. Then we've got PV, which is the yellow. And you can see that it generates at around noon, and it's up and down, which is what PV does when the clouds come over and things like that. Then you've got some biofuel, that's the green line, and at 6 in the afternoon till around 10 at night, we have a spike, and that's when biofuel kicks in. And it comes up and it tapers off and it runs a little while, and then it goes into what we call spinning reserve. It just sits there. And the top brown line, that's oil. And so we use oil to modulate all of these other renewable resources. So when PV is operating, oil shuts down a little bit, and then when as demand increases, oil kicks in, and as demand decreases, oil is reduced.
And what we're trying to do as a state government is bring electrical generation to zero oil, zero fossil fuel.
Absolutely.
Yeah.
One of our problems is that, you know, we're contributing to greenhouse gases, although not as much as, say, China and North America, but, you know, we're using coal. I mean, why are we importing coal when we have more sunlight than any other state in the nation, okay? And one of the problems with wind, and I like wind as a renewable resource, however, in the last 30 years, we've had 23% fewer windy days.
Yep.
And we're having less and less wind. So wind might not be Hawaii's best answer.
Yeah, we've got the farms up there. We certainly use it. But,
Absolutely, yeah. But are they producing what they should be producing? I'm not sure.
So what do we have up here now?
Okay, so this is our plan for the DER. See, a DER, distributed energy resource, is built around a battery, a large scale storage battery. And our 1.4 megawatt battery is housed in a 20-foot container. The other technologies are all housed in the 53-foot containers. They also have auxiliary heating and cooling systems. Our system does not require that. And so our batteries will take the PV and the wind and store it, and will also be charged off the grid. And our energy cloud will manages all of this, and so we feed this energy into the grid at various locations around the grid, and that's what a distributed energy resource is.
Yeah, and it's all back and forth, back and forth. The utility has computers which are communicating with these computers, and I think it's an instantaneous communication.
Yes.
Say a cloud passes, battery goes up, sun comes out, battery goes down.
In the best case scenario, that's the way it works.
Mm-hmm.
Yes, and actually the systems that we've been using have been vetted in Europe over the last 20 years, so it's not rocket science,
Yeah.
and it's not new. And as a matter of fact, I have a cell phone here that was monitoring one of our power plants on the mainland, and I'll crank it up later. But anyway, our company and our partners have been monitoring and controlling power plants off of cell phones since 2002.
Spooky
So,
stuff.
yeah.
On that cheery note, we need to take a break. We'll be right back.